Today we will try to understand the identification of rocks. Now, first of all, once we say rocks, means it may be igneous, sedimentary, or metamorphic. Now, first you should try to distinguish whether it is igneous, sedimentary, or metamorphic. You all know igneous rocks, they are tough, frozen melt with little texture or layering, mostly black, white, or grey mineral. So, this you try to make. The sedimentary rocks, they are hardened sediments with layers, strata of sandy or clay stone. Brown to grey may have fossils and water or wind marks. Means you will see the bedding, the layered strata, relatively soft, will be having fossils or water. Now, third category, that is your metamorphic rocks. They are tough rocks with layers, that is called foliation, of light and dark minerals, often curved, various colors, often glittery from the mica. So, first of all, because once we say the hard rocks means either your igneous or metamorphic rocks. The sedimentary rocks, they are called as the soft rocks and having the layers or the strata. So, first, once you are given hand specimen of a rock, you just try to distinguish, means whether it is igneous, sedimentary, or metamorphic, then proceed. If it is, suppose you find that rock as a tough, hard with texture, black or white, right? Then coming to this identification of your igneous rocks, you can see in the table. Once we say, right, say this is the first category, this coarse grained. Coarse grained, you all know, igneous rocks are those which have the grain diameter more than 5 millimeter. So if you recognize that the diameter of the different minerals present in the rocks are more than 5 millimeter, the diameter, and the color says light colored, light, the then means the color is like, once we say light colored means it has more felsic minerals like granite with or without quartz, right? You can see in the table. Now the composition is once it is a light colored feldspar with minor mica or amphibole, there is a cyanide. Same once we say coarse, medium to fine grained, right? This is coarse, medium to, you can say dark colored, little or no quartz, right? Then the rock can be your look having low calcium plagioclase. The rock can be your diorite. Similarly, if rock is coarse grained, medium to dark, having no quartz, may have olivine, high calcium plagioclase, dark minerals, the rock is gabbro. So likewise, if you can categorize, means rocks which have coarse grain size that is more than 5 millimeter in diameter, right? And then come down to their color, light colored, whether it is light colored, medium to dark or dark green, and you can say colored. Now this is last category. This is your last category, very coarse, means extremely coarse grained, any color, usually intrusive bodies, physically, this the rock is pegmatite. You all know pegmatite is also known as museum minerals. And the character of the pegmatite rock means it crystallizes in the end stages of the crystallization of the magma. And the pegmatite, they have extremely coarse grain size. This is also called the museum of minerals. So they are the last residual constituents which are left in the magma, they crystallize as pegmatites. Once we say the rock is coarse grained, dark colored, right, having olivine as an essential mineral, say, then that rock will be called as the dunite, right? That is the 90% olivine, that will be dunite. If it is again coarse grain, dark, if it is having pyroxene and olivine, then rock will be called your peridotite, right? So like this, we have to first come down to the textural grain size, then the color, then ultimately the name. Now the identification of igneous rocks, if it is a fine grain, on the other side if we take, we have talked of the coarse grain size. If it is a fine grain, glassy appearance, lava glass, that rock type will be the obsidian. Naturally, once it is a fine grain means it is a volcanic rock, and the color, if it is a dark glassy appearance, have lava glass, the rock will be obsidian. Again, if a rock is fine grained, of light color, many having other many small bubbles, lava flows, froth from sticky lava, that rock type will be the pumice. Then again, if a rock is fine grained, is a dark colored, many large bubbles are present, have froth from the fluid lava, rock will be scoria. Again, if a rock is fine grained or mixed, is light colored, contains quartz, high silica, the rock is felsite. If a rock is, say, medium grained and it is between felsite and basalt, medium silica lava, the rock will be andesite. So overall, once we say these means these volcanic rocks, they will have fine grained. Once we say porphyry, means it is a mixed, any color, large grains in fine grained matrix, that will be your porphyry. Then the coarse grained, once we say, means light colored, wide range of colors, feldspar and quartz with minor mica, amphibole or pyroxene, the rock will be the granite. Now I will show you, or you can see here, the different rocks, because once you see with your naked eyes, in the megascopic the rock types, though the various physical properties and all the texture, mineral composition are there, but that is last in our memory. So this is rock type right now, you can see it here. This is the obsidian, right? Similarly, the next you can know, this is the pumice. Now these are the vesicles, pupils. Then the next rock type, this is your scoria, large bubbles. Then next is your, this is felsite. Just try to see the sample. From this you will have an perception in your mind of the rock felsite. This is your andesite. This is naturally is a volcanic rock you talked of earlier. Now this is your typical basalt. This is a vesicular basalt. The number of vesicles are present. If these vesicles get filled with your secondary minerals, it will be called amygdaloidal basalts. Now in volcanic rocks, what happens? These gases, they escape to the atmosphere and cavities are formed, or you can say the empty or void spaces are formed, and these are called the vesicles. So generally the basalts which are the vesicular, they get filled with the secondary minerals, and that will be called the amygdaloidal basalt. Now this is in porphyry, in the sense means these are large grains that are present in the finer grain. So in general we say the porphyry. Now this is what you see as a porphyritic texture also. So it is easy, means if you go back to our textures, a rock, igneous rock, if it is having equigranular size and the grains are coarse grained, naturally that is a plutonic rock. If a rock is having fine grained or glassy, it is a volcanic rock. But if a rock has both fine grained as well as your coarse grained, so these coarse grained, they will be called the phenocryst, and they appear to be embedded in the fine grained ground mass. So such textures, they are called the porphyritic. Now depending upon the nature of ground mass and the phenocryst, these are further subdivided into, you can say, different. The naturally the phenocrysts which are large, we can understand from the Bowman reaction principle that they crystallize early under slow cooling conditions, but later on the, the magma is implaced upwards. Along with these crystals, the rest remaining liquid crystallizes fine grained. So we make a sense that the phenocrysts, they crystallize earlier than your ground mass. Simple story or simple form to understand is that when a magma is implaced, right? So in the depth, naturally there is a slow cooling and large crystals are formed. When it is implaced, the remaining liquid naturally will crystallize faster. So today we'll see a rock having two types of grain size, large ones and the small ones. Naturally large ones have crystallized under slow cooling conditions, whereas the smaller ones, they have crystallized under the rapid cooling conditions. And then result is your, you can say that as a porphyritic texture. So this is common in your hypobasal rocks. These such textures are common in the hypobasal rocks. So the rock is named on the basis of texture and the mineral composition. First we have to understand that the overall makeup of the rock. Then we have to see the texture aspect and then the mineralogical aspect, and then ultimately we have to, on that, because a rock is named on the basis of texture and mineral composition, we designate that rock into that category. So this is how you should proceed for the classification or say for the identification of different rock types which are there. Now this is what we seen earlier. Next you can see a rock type. This is typical. What you see here, because almost your dark minerals and the mafic felsic minerals, light colored minerals, you all know that light colored minerals, they are either quartz, feldspar. The dark minerals may be minerals of mica group, amphibole group, pyroxene group. Now this rock is made up of, and it is a coarse grained rock. So this rock you can categorize in the sense depending upon if the minerals, mafic minerals, they are restricted less than you say 30%, it will be granite, and if they are more than that 30 to 50, that it will go to diorite, because both are plutonic rocks. So that will depend upon that nature. Now see this rock type. Here the mafic minerals are more. So naturally this rock will go towards the gabbroic side. The light colored, these are plagioclase feldspars, whereas the dark, they are your pyroxenes, amphiboles. Right? So this rock will go to them. Further, if you see it here, relatively there are more mafic minerals. What I have shown you, I have tried to make you understand on the basis of the texture, the different rock names, and now I am trying to explain you that on the basis of the ratio of the felsic and the mafic minerals. Felsic minerals, you all know, they are the light colored minerals. They are maybe the mineral of quartz, maybe of feldspar family, maybe of feldspatite family. Whereas your dark minerals, they may mica, amphibole, pyroxene, olivine. Right? The nature of this, in this sample you can see it. The mafic minerals or the dark minerals, they dominate the felsic minerals. Now the next is, this you can see it. This is all your olivine, the green colored one. So naturally this will be your rock dunite. Right? So likewise you can make it. Again this rock type. Now this is all about the igneous rocks. We will take up the study of metamorphic rocks or the identification of metamorphic rocks in our next video. Thank you very much. See you in next class.